Hi everyone. So this was the second coding question which got asked today in 26th March morning shift. Okay. So we will be solving this. Okay. First of all, I want to discuss about this. See, I don't know because I was not giving the exam, but if the recursion logic was working for this question, then this question is easy. And if the recursion logic was not working for this, then there is a concept called cycle that we will be discussing in this video. So that solution I would say will be little bit difficult to find out for the students who never solved the questions which are related to cycles. Okay, because this question was based on cycles. Okay, so if you have never studied about cycles, then this question can be felt difficult. But if the recursion logic was working in this question, like the logic was passing the test cases, then I think this question is easy. Okay, so I will be talking about both the test cases. Okay, so basically this question says we have an input like this. Okay. Okay, so before going ahead with this, we have a mock test series which is TCS NQT mock test series. There are a lot of live tests which are going through, so you can go through it. The link of the mock test series will be in the description. You can attempt the live test before your exam if you have your exam on 1st April, 3rd April, or in the April month. And these live tests will help you out to actually perform well in your exam, because the questions will be very similar what TCS will ask in your actual exam. Okay, so the mock test series link will be in the description, which you can use for your preparation. So let's discuss about this. So see, basically this question says a array A, the formation is 10, 20, 50 and 40. For array B, the formation is 50, 20, 40 and 10. Okay, we need to transform the eighth array in eighth B array of B. Okay, and basically when we want to transfer, we will be doing the swaps. We will be swapping and we want to find out the minimum operations. Okay, so if I will perform the swapping operation, what I can do is I can check here. Okay, I can check here 50. Okay, if you will see here. Okay, so 50 I can swap here with with 40, right? So one swap will be this, so it will be 10, 20, 40 and 50, right? So this is the first swap. Second swap I can do is I can swap 10 with 50. Okay, so it will be 50, 20, 40 and 10. So this will be my two operations. Okay, this will be my two operations. Okay, in these two operations, I can transform this array A into the array B. This was the question. Okay, so two operations will be required. I can swap any two elements. Okay, so minimum operations we need to find out. So two operations will be there. Okay, now see, if we want to implement the recursion logic, I think the recursion logic is very easy. Okay, and based on that, if the TLE error was not there in the exam, then I think this question is easy. If the TLE error was there, I don't know about it, then this question is tough. Okay, so the array is saying 10, 20. What is the array? 10, 20, 50, 40. Okay, 10, 50, 40. This is the eighth array. Okay, and our bth array is 10, oh sorry, 50, 20, 40 and 10. Okay, so by using the recursion array, what we can do is okay, I will run my recursion logic here. I will run my recursion logic here. Okay, and I will swap the elements. Okay, I will swap the elements and I will be counting the operation. So what I will be doing here, I will be matching the index. Okay, I will be matching the index. So if I will make the index of this, then this is 0 index, 1 index, 2 index, or 3 index. Okay, now based on these index, I will be checking with these elements. Okay, so 50 will be on third index, so it will be 3. Okay, 20 is on second index, it will be 2. 40 is on fourth index, it will be 4. And 10 is on first index, so 1. Or I can say it is 0, 3, 0 based indexing, 1 and 2. Okay, so this is the index of B based on A. Okay, now based on this index, okay, in recursion I can swap the elements. Okay, based on the index, right? So swap 0 with 2, right? swap zeroth index with second index. Okay, so I can swap this and I can do count plus plus. And then I will again pass the whole array in my recursion function. And that way I will be computing the minimum operations. Okay, I will be making one variable which is minimum operation, which will be storing all the swaps, which I will be passing in the function, and that will store our final count. Okay, but this approach will take a lot of time complexity, right? I hope the approach is simple and clear, but it will take a lot of time complexity. So I am not sure if it will work or not. So we will be discussing the approach which is called cycle. Okay, cycle detection. So see, if you have done any question previously related to cycles, okay, I think this approach will be easy to you. If you don't know how to detect the cycles in the array, okay, then this approach can be felt difficult to you. Okay, so basically there is a concept called cycle. I will be not going in too detail, but a cycle concept is there in the arrays when some elements are pointing out the other element, and they again are pointing out to some other element. Okay, for example, if I will convert the indexes here, so again, if you will see here, this is zeroth index, this is 1, it is 2, and it is 3. Again, if I will convert the indexes from here, it is second index, it is 1 index, it is third index, and if it is zeroth index. Okay. So actually at the place of 0, it should be 2, right? If we will do the swaps. So at the place of 0, it should be 2. At the now, if I talking about 2, so I will go to the 2 and I will check here. At the place of 2, it should be 3. Okay, it should be 3, right? And at the place of 3, it should be 0. So now if you can see here, at the place of 0, it should be 2. At the place of 2, it should be 3. And at the place of 3, it should be 0. So this is a cycle, right? This is a cycle. Okay. And if the input is long, there can be multiple cycles like this. Okay. And if we want to sort out this cycle, like we have 0, 2, 3. Okay. We have cycle between this. Okay. How many elements are there? Total 4 elements. If we will see in the cycle size is 4, right? But how many elements are there? Total 3 elements are there, right? So how many swaps actually it will be requiring? It will be requiring elements minus one swap. Okay, elements minus one swap. Okay, why? See, if I have three positions and I want to settle down A, B, C on these three position. Okay, and these on these three position I want to settle down A, B, C. If I will decide where A will be sitting, where B will be sitting, automatically the place of C will be there. Okay, so only we need to decide two places, right? So that's what we will be doing here. If we will be arranging three elements, in the arrangement of three elements, if we will be doing two swaps, for the third element, automatically it will be on the correct position. Okay, so that's why the count of the swaps will be 2, right? So for this cycle, if you will see here, the count will be 2. Okay, because see, we have three elements 0, 2, and 3, and if we will place 2 and 3 at the right point, automatically 0 will be following the right place, right? That's why the value of the swaps will be 2. Total number of elements minus 1. Okay. Okay, so after swapping these 0, 2, and 3, our array will be in the correct manner like B. Okay, so the final answer will be 2. This is called the cycle concept. Okay, and yes, there can be the multiple cycles, but the thing is, if there are multiple cycles, suppose there is a cycle like this, okay, like 0 is pointing 2, 2 is pointing 3, 3 is again pointing 0. Then again we have a cycle, suppose 5 is pointing to 7, 7 is pointing to 8, 8 is pointing to 6, and 6 is pointing to 5. Again, this is a cycle. Okay, suppose these two cycles are there in a big input. So the count from this, okay, will be 2, and the count from this, like 4 elements are there, will be 3. So total number of swaps required in this array will be 5. Okay, 3 plus 2. So this logic we will be using here. Okay, the cycle detection thing we will be doing here, and this is the optimized logic. I hope the logic is clear, but I just wanted to clarify you with the example once again. Okay, so it will make more sense. Our eighth array, the value of eighth array is 10, okay, 20, 50 and 40. Our value of bth array is 50, okay, then 20, 40, 10. Now listen me carefully. First of all, we will be finding out the positions of this and we will be mapping the position to the bth array, okay. So 10 is on 0, 20 is on 1, 50 is on 2 and 40 is on 3. If I will do the mapping of the position, see the position of 50. 50 is on 2 position, so 2 will be mapped here. On 21 will be mapped here. On 43 will be mapped here. And on 10, 0 will be mapped here. I will start with index 0. Okay. I will start with index 0 and I will check if the element is at the proper position. So if I will say here, so on the zeroth position, it should be the second element, okay, because see here the mapping, okay, on 0 it should be second, okay. So I will start from here, okay, and okay, on the zeroth it should be 2, okay. So I will increase my cycle here, okay. If it should be 2 here, I will be directly going to the 2 position, okay, second position. So when I will go to the 2 position, I am just visiting to the position and I am counting the total number of elements. So here if you will see here, the total number of elements here is now 2, 0 and or you can say count here is 1, the length of the cycle, okay, the length of the cycle is 1 here, okay, from 0 to 2, okay. Now I move to the second position. On the second position, if I will see the mapping, it is pointing to 3, okay, it is pointing to 3, okay. So 2 is pointing to 3, so I will go on third position here. If I will see here on the third position, it should be 0, so 3 again is pointing to 0, okay. So now see the length of cycle. The cycle length is 1, 2 and 3. Total 3 length is there between the cycle, okay. If the length of the cycle is 3, okay, the swaps required will be 2. So my count of the swaps will be now 2, okay. Now I have count 2, okay. After this count 2, okay, after this count 2 and after all these swappings, I will check from here, okay, and every swapping, when every swapping is done, okay, when every swapping is done, basically if every swapping is done, and I will be checking if all elements are visited, okay. So right now, if you will see here, we have visited the 0th index, so we will mark this as visited, okay. We will visited second index, so we will mark this as visited. We have visited the third index, so we will mark this as visited. Any index left, first index, this is left. So now we will check here on the first index that is it visited or not. So it is not visited, but now we will be checking the position. At the second index, it is 1 and the position is 1. So both are same. If both are same, no cycle detection required. We will move with the another element, the next element, but this is already visited, this is already visited. So our array is completed and our final answer is 2. Total number of swap required are 2. Okay. So this is the logic here. I hope you guys got it. If you have not got it, again, please watch this video again. Now, let's talk about this. So whatever we have discussed in the logic, we will be doing the same. First of all, we are mapping the position here. I have created one map. After creating the map, okay, I am assigning the position. Okay, so position, if you guys remember, we have assigned the position to the index right here. So 50 will be 2, 20 will be 1, 40 will be 3 and 10 here will be 0, right? So the same thing we are doing here. We are assigning at the position map all the indexes for B of I, okay? After that, we have created one visited array, which we just discussed. The value of swaps is 0. Then we started our loop. We are checking if the if the number is visited, okay. If the number is visited and okay, and if the position is matching with the mapping position, so the eighth position is matching with bth position, we can continue our loop, right? And the element is visited, okay. If it is not visited, the cycle size is currently 0, okay. The cycle size is currently 0, okay. We will be assigning the index value to our variable j. Then we will be running one loop, okay, visited, okay, from visited. So in this visited loop, we will be detecting our cycle. How we are detecting our cycle? We are starting our loop not visited. Okay, so suppose our cycle is like this: 0, 2, 3, then again 0, right? So we are starting with 0, right? So currently it is not visited. Okay, then we will mark this as visited. Okay, after marking this as visited, which we have done here, okay, we will be going to the mapping position. So for 0 the mapping position was 2, right? So we are going from 0 to 2. So we are assigning that mapping position here to J. Okay, so the mapping position we assigned. Okay, after assigning the mapping position here, we are increasing the size of cycle, right? This is the thing which we have done. After that again, okay, we will be checking here if it is visited. So no, 2 is again not visited. Okay, so we will mark 2 as visited. After that again, from 2 we will be going to the mapping position. The mapping position of 2 is 3, so we will visit to 3. Okay, and we will be increasing our cycle size to 2. Okay, then from 3 again we will mark this as visited. Okay, from 3 we will be going to 0 again, because the mapping position of 3 is 0, so again we will be going to 0. But 0 is now visited. We will be doing cycle plus plus, so the size of cycle will be now 3. But 0 is visited, so this loop will be ended. So our cycle will be looking like 0, 2 and 3. Now cycle size is 3, so number of swaps will be required, will be cycle size minus 1. So the number of swaps required will be 2. Okay, and that way we will be returning our final swaps. Okay, so and this loop will continue, the I loop will continue, going to check the multiple cycles. Okay, at last we will be returning our swaps, and this will be our final solution. So I hope the logic is clear. And if you have any doubt, see, from my side I tried my best to explain in the simplest way. This concept is not easy. If you are finding it difficult, please watch this video again and you will be getting it. This is the Java solution, and this is the Python solution. Okay, thank you so much for watching.